Let's say you want to create a top-of-the-line image classification algorithm, and you're going to use this for autonomous driving, so performance is critical. A recent Google study shows that for the same algorithm, performance increases logarithmically with data. So we need massive amounts of data to increase our average precision here. How would you even begin building a system like this? You could think of something like this, where you just have a database and you download images from the internet. But here you're limited by your database speeds, your network connection, and even where you're getting your images from. So let's think of a better system. You could have something like this, where you start with a MongoDB database that shards across multiple machines well and scales exceptionally well. Then you can assign tasks to a bunch of different Docker workers, and they'll do your downloading for you. This is kind of how torrenting works, and you can expect a speed up from this, but the biggest advantage is that now we can have a bunch of different MongoDB databases sharing this information, and we can create a massive database system so we can store even larger image sets. Next, I'm going to walk you through how these Docker workers work and how you can build your own database like this. Now I'll be demonstrating our Docker download functionality. This will allow us to run a command on a worker node and download images to a remote MongoDB database. You can see here on the left we have our MongoDB database. Right now it has 7 collections. You can see that images are stored here. I'm going to be adding a new collection called pics so that we can really clearly see that I've added something with our Docker download. Docker download takes as an input a car.txt file. Car here is our category. This can be changed. And you can see that it has an ID for the image, the source URL, and then the name of the website. And this name of the website can be used to check the robots.txt file, which shows us if we're allowed to download the image. It can also be used to check a blacklist for websites that we don't want to download from. So now I'll run the Docker. You can see that I'm specifying a category of car, and it's going to take as an input car_0000.txt. You can see that it loads it, and then that it downloaded 2 images into our database. So we can go over to our MongoDB database and check and see if we have a new collection. You can see here that we do. We have pics now, which has 2 images. Okay, so now we have our MongoDB database. We have tons and tons of images that we've downloaded from the internet. And this is what it looks like. Of course, as I said before, this MongoDB database can still be spread out over several machines, but this is our overview. Once we have all of these images, what do we do with them? How do we make them meaningful? First of all, for a machine learning algorithm to work, we need to have ground truth data. This is data that the algorithm knows to be true. For example, in our case, that would be an image that it knows for certain contains a car or does not, and it has to get that information from humans. So we take our MongoDB database and we'll connect it to a Golang server. This Golang server exposes some of these images to the internet. It collects and groups the MongoDB images into tasks and then feeds those tasks to the Amazon Mechanical Turk workers. Amazon Mechanical Turk is a service that allows people to do menial tasks for money. So here we can see that we're connecting our Golang server to several mturk workers where they'll start labeling images. You can see that we've done these websites in React, and React is much more scalable and easier to develop with than other JavaScript frameworks, other web development frameworks. So this will help future developers as they seek to improve our system. Next, I'm going to walk through how we interface with Mechanical Turk and what setting up this server looks like. Now let's run through how we'd actually run this front end. First, we're going to start our Golang server on our local machine. This is what's going to manage the connection with the MongoDB database and serve the images from that database to our workers. So now that we've started the Golang server, we're going to publish it to the internet so that it can actually be useful to Mechanical Turk. And here we can see our MongoDB database, and you can see that right now we have 6 workers, 0 through 5. So we're going to add a worker. We're going to do that by creating what's called a HIT, which is a human intelligence task. So now I have this HIT ID. We can go to our email and see that we have the task published, and we can click on the link to complete it. So what this task is going to be is it's just going to be binary labeling of images. For this particular task, that means telling the website whether or not the image contains a car. So you label the images with left or right clicks of the arrows on your keyboard. You can see at the top that a reward is given. And while the user is doing this, we're running analytics in the background to measure how long it takes them to label each image. And this helps us see how hard the images are, make sure that our workers are proficient, and that no bots are running. So we're running a little fast here for demo purposes, but we're running through what an actual worker would see if they did it. So you can see there are a lot of images here. After the worker's done, we'll go back to the database and show that the data has been updated. We now have an additional worker, number 6. At this point, we've seen the entire pipeline. We've seen how we pull images from the internet into a MongoDB database, and how we take those images and give them to Mechanical Turk workers for labeling our ground truth data. What I didn't talk about was that people outside of the group have been working on an active learning pipeline where machines can label these ground truth data for us, and we don't have to pay humans to do it. This is incredibly important for building larger and larger data sets, but it's not something that the people in this group have worked on. Our hope is that coupled with the active learning pipeline, this work, when made open source, will lead to safer autonomous cars sooner. Thank you.